Welcome guys to a video on electromagnetic spectrum. It's part 2. In this video, we will understand how various wavelengths and frequencies of radiations are made use of. We all know sun and all the celestial bodies like the moon, the black holes, the dark matter, the pulsars, even planets, stars, quasars are all the main source of all type of radiations. These bodies keep on continuously emitting and absorbing all various types of radiations. Some of them are useful while some are harmful to us. However, our atmosphere, that is water vapor, carbon dioxide, oxygen and the ozone layer shields us from the harmful radiations, and hence only we are able to survive on this planet. So in this video, we will see which are useful and which are harmful radiations and how even the harmful radiations we have put to our application. So let's get started. Before going to the application parts, let's have a quick revision of what we understood in electromagnetic spectrum 1. We had understood that charged particle will produce electric field and magnetic field such that they oscillate perpendicular to each other. And this is actually the Maxwell's theory. In your higher grades, you will have this Maxwell's theory where you will learn the equation which will give you the relation between electric field and magnetic field. So right now you need to understand that any charged particle when accelerated by an electric field will produce electric and magnetic field which are perpendicular to each other and perpendicular to direction of their propagation. The oscillations are transverse in nature and the electromagnetic waves travel with speed of 3 into 10 to the power 8 meters per second in vacuum. However, the velocity decreases to a small value when it is in a medium. Also, I shared you a mnemonic to remember the sequence of electromagnetic spectrum. That is, Radio Mirchi invaded Victoria with ultraviolet X-ray guns. That is, radio, microwave, infrared, visible, ultraviolet, X-ray, gamma rays. Then we also saw from left to right the wavelength is decreasing and the frequency is increasing. For electromagnetic radiations being the transverse rays, the velocity is a constant value, that is 3 into 10 to the power 8 meters per second. If this velocity has to be constant, then the product on the right hand side are inversely proportional of each other. That means if lambda is decreasing, the frequency has to increase and vice versa. That is what we see here, decreasing wavelength, increasing frequency. We also saw the range into which these various radiations fall. But I also told you not to remember these values. These are not strict values. These are not the strict, especially at the boundaries, they are not strict. For example, if we consider the visible range, in some books they also give from 700 nanometers to 450 nanometers, or in some textbooks, reference books also they give 800 nanometers to 400 nanometers. So these are not very strict boundaries. They merge or fade into each other and there is continuity of the radiations. There is no parts like no gap in between. There is continuity in the electromagnetic spectrum. Also we know E is equal to H into F, where H is the Planck's constant and F is the frequency. Here we can understand that E is directly proportional to F. The constant of proportionality is H, which is called as Planck's constant. Right now we'll keep H aside. We'll just understand E is proportional to frequency. So as the frequency increases, the energy also increases. So for these radiations, towards the right side of the visible range, the ultraviolet, X-ray and gamma ray, they have high frequency, hence their energy is high. Whereas the spectrum to the left of the visible range has low frequency, hence their energy is low. Now because of high frequency for these radiations, that is ultraviolet, X-ray and gamma ray, they have high energy and the energy is able to remove the electron from the atom. Such type of radiations are known as ionizing radiations. While those radiations to the left of the visible region are known as non-ionizing radiations. So this you should remember. Ultraviolet, X-ray, gamma ray are known as ionizing radiations because they have high energy due to high frequency and hence they are able to remove the electron from the atom. Whereas the radiations to the left of visible region, that is radio, microwave and infrared, are known as non-ionizing radiations. Now one more term, that is hertz, with respect to hertz, that is frequency. We always frequently use these terms 1 kilohertz, 1 megahertz, 1 gigahertz. So 1 kilohertz means 10 to the power 3 hertz, 1 mega means 10 to the power 6 hertz, 1 giga means 10 to the power 9 hertz. So when it comes to hertz, that means we are talking about frequency. When it comes to micrometer, nanometer or picometer, we are talking about distance or the length of the wave, right? So let's start with radio waves. The first radiation of our spectrum, the radio waves. The frequency is less than 3 into 10 to the power 11 hertz, whereas wavelength lambda is 1 kilometer to 1 millimeter. Now the source, all the radiations, as I said at the starting of the video, the main source, the primary source or natural source is the celestial objects or the space. However, they can be produced when electric charges oscillate. So applications now, because these are the longest wavelength, 1 kilometer to 1 millimeter. So these are the longest wavelength, hence these are used in radio and television communication system. Next is the microwaves. Microwaves, the frequency is 10 to the power 11 hertz to 10 to the power 13 hertz, whereas wavelength is 1 millimeter to 25 microns. Now this wavelength is very small as compared to the wavelength of the radio waves. Radio waves is 1 kilometer to 1 millimeter, whereas this is 1 millimeter to 25 microns. Hence the name as microwave. So compared to radio waves, the wavelength is small, hence these are called as microwaves. Now the main source, as we know, the celestial objects, but we can generate them using vacuum tubes like klystrons, magnetrons and gun diodes, wherein the electron is made to accelerate to a very high speed. Now obviously the applications we know is the micro oven, which uses microwave. Then it is used by aircraft to land safely. Then it is used in radars so as to detect the range, the speed and other characteristics of remote objects. Especially the police people also use this for monitoring the speed of the vehicle. Then in wireless, walkie-talkie, for communication, broadcasting, we use microwaves. Then comes infrared, which are also known as heat waves. The frequency is 10 to the power 13 to 10 to the power 14 hertz and wavelength is 25 micrometers to 750 nanometers. So wavelength is decreasing, frequency is increasing. Now the main source infrared or heat waves come from sun and fire. Any object which has temperature radiates in the infrared. So even we have temperature. So we are also continuously radiating infrared. So any objects, all objects above minus 273 degrees Celsius or absolute zero, wherein the particle stops moving. Reaching this is difficult, but any objects, because of which any object above this temperature will radiate infrared. Hence, even objects that we think of being as very cold, such as ice cube, emit infrared because this is above minus 273 degrees Celsius. Now the applications for this will be, these are used as heat sensors in thermal imaging and night vision equipment. Night vision equipment, thermal imaging, basically these are used by defense people to monitor the movements of the enemy. So whatever radiation heat waves are coming from them, through those radiations they can make a picture of the enemy. And heat waves or infrareds are also used by missiles so that they can follow their targets based on IR radiation of the target. Then is the visible, where the frequency is still higher, 4 into 10 to the power 14 Hertz to 7.5 into 10 to the power 14 Hertz, and lambda is now decreasing, so 750 nanometers to 400 nanometers. Visible, so obviously the source, main sources, sun, torchlight, fireflies are the sources, and application obviously to see, photography and illumination. Next is the ultraviolet. Ultraviolet, now the frequency is still higher. So these are in the range of or for ionizing radiation. So from ultraviolet, ionizing radiation start. The frequency is increased. That means the energy will increase because energy is directly proportional to frequency. Frequency is 10 to the power 15 to 10 to the power 17 Hertz. Lambda is 400 nanometers to 1 nanometer. Lambda has decreased. Now the source is sun, as we know, is the main source of ultraviolet waves, produced either by heating a body to high temperature or by passing an electric current through a gas, usually vaporized mercury. So these are the sources of ultraviolet waves or radiations. Applications, it is widely used in industry by industry for curing, that is to dry inks and resins, means paints. Then it is used in medical and dental practices, especially to kill the bacteria or sterilize the equipment. If you had been to a dentist, they always have this cupboard where ultraviolet rays are being made incident on their equipments, whatever the tools they use. So those are actually used to sterilize the equipment. Then phototherapy for certain skin disorders, and sun tanning to produce vitamin D. Then X-rays. How are X-rays produced? Now these are also very high frequency ionizing radiation. They are having frequency of 10 to the power 17 to 10 to the power 20 Hertz and wavelength of 1 nanometer to 1 picometer. So small wavelength, and these are produced when high speed electrons will hit the metal targets. And where do we use them? X-rays are used to detect or find the fractures, the broken bones. Then these are used to spot the pneumonia, chest X-rays. Then once again to a dentist, when we go, they take X-rays to check how much the tooth has decayed. So X-rays is also having medical applications, though these are very harmful. One has to be very careful while using. Coming to the last radiation of the spectrum, that is the gamma rays, which have frequency of 10 to the power 20 to 10 to the power 24 Hertz and wavelength less than picometers. Pico means 10 to the power minus 12 meters. So wavelength is very small, but the frequency is very high, 10 to the power 20 to 10 to the power 24 Hertz, and it is the most hazardous radiations that we have in our electromagnetic spectrum. Obviously X-ray and ultraviolet are also harmful. Now gamma rays, the obvious natural source is the space, the universe, where neutron stars and pulsars, supernova explosion, region around black holes produce tremendous amount of radiation that is hot and most energetic. While on the earth we can have them radiated by radioactive elements. Now applications, though these are very harmful, hazardous, we still can make use of them if used in an appropriate way. So we can use them for sterilizing food and in medical equipment, and also in detection of cancer and its treatment, because these are ionizing radiation. So once we know there is cancer, we can kill the cancer cells using gamma radiation. So guys, that's all in the application. I hope I have made each radiation applications very clear to understand. I do have a question for you. Please put down in the comment box which radiations are made use in our TV remotes. And do like, share and subscribe the channel for more such videos. Also do hit the bell button besides the subscribe button. Thank you.